let's have a look at question 4. So this is a projectile question. Let's have a look. A small stone is projected with speed 65 meters per second from a point O at the top of a vertical cliff. So we can resolve this straight away. So one vertical and one horizontal. So vertical is the opposite of the angle. So that would be 65 sine alpha. And the horizontal is the adjacent, which is 65 cos alpha. Point O is 70 meters vertically above the point N, which is already labeled in here. And then point N is on horizontal ground. So the stone is projected at an angle alpha above the horizontal, where tan alpha is 5/12. So we can resolve it straight away. So this is alpha, so opposite has to be 5, and then adjacent has to be 12 because it's 10, hence opposite of adjacent. And then using Pythagoras theorem, square root of 5 square plus 12 square, and then that would be just 13. Then we know sine alpha is 5/13, and then cos alpha equal to 12/13. And the stone hits the ground at point A as shown in figure 3. The stone is modeled as a particle moving freely under gravity. Acceleration due to gravity is modeled as having magnitude 10 meters per second square. So if they use 10 meters per second square, you have to use it. You don't use 9.8. And then using the model, find the time taken for the stone to travel from A to O. Okay, let's see what we know. So because they ask us to find the time taken for the stone to travel from A to O, we don't know the horizontal distance. So that means we can't really use the horizontal component because the horizontal is just constant velocity. Velocity times time give you displacement. So if you don't know what displacement is, to work out the time, that's not possible. So we have to use the vertical direction. So for the vertical direction, we know the initial velocity u is just equal to 65 sine alpha, and then we know sine alpha is 5/13. So you can just times them. So 65 times 5/13, that would be 25 meters per second. And we know acceleration is negative because it's projected up. So it's against the gravity. So it has to be negative 10 meters per second square because they said use 10. So we use 10. And then S has to be negative 70 because we projected upwards initially. So we treat the upwards as a positive direction. So A is below the initial position. So it has to be the opposite of it. So it's negative 70 meters. And what we're looking for is time. That's what we don't know. So if we know S, we know U, we know A, we don't know T, we have to use S equal to UT plus half AT squared. So U, we know, is just 25. And then T is what we're looking for. And S is negative 70. So plus half times by A, negative 10, T squared. To simplify that, we have negative 70 equal to 25T minus 5T squared. And then move everything to one side. 5T squared minus 25T minus 70 equal to 0. If we move negative 5T squared and then 25T to the other side. So then put into the calculator 5, negative 25, and negative 70. We have T is equal to either 7 or T equal to negative 2. Clearly, negative 2 is not valid because time cannot be negative. So T equal to 7 is our final solution. Okay. And now we know the time for part B. They want us to find the speed of the stone. So if they ask for the speed, so speed is the magnitude of the velocity. And then velocity has direction. So you have to use both horizontal and a vertical component, and then do the magnitude to work out the speed. So in this case, the horizontal direction is very simple because the horizontal velocity never changes. So then in the horizontal direction, u is just equal to 65 cos alpha. And then we know cos alpha is 12 over 13, which we already got it from before. So then 65 times by 12 over 13 is equal to 60 meter per second. That's the horizontal velocity at point A, because it never changes. And then for the vertical direction, we know S is negative 70. And then from before, we know initial velocity is 25. And then A is again negative 10, but now we know time t is equal to 7. And we're looking for the final velocity. So clearly, V equal to U plus AT is the simpler formula we can use. Because we know U, we know A, we know T. We just want to work out the final velocity V. So substitute in straight away, 25 plus A negative 10 times T 7. Then 25 times plus negative 10 times 7 is the same as 25 minus 70, which is negative 45 meter per second. So now we know the velocity in the vertical and the horizontal direction. So we can just do Pythagoras straight away, but make it easier for you to see. I can draw it out. So horizontal is positive 60 meter per second. So then it should just be 60 go to the right-hand side, because positive means the same direction as before. So the direction didn't change. And then for the vertical direction, it's negative 45 meter per second. So we know initially it goes upwards, and then now it's negative. That means it's opposite to the direction as before. So it has to be goes downwards like that. And then 65 meter per second. I mean 45 meter per second. Then we just have to find the magnitude, so which is just the hypotenuse. So to work it out, V is just equal to square root of 60 squared plus 45 squared. And then put in the calculator, that should give us a final answer. So 60 squared plus 45 squared and square root it, that would be just 75 meter per second. That's it. And then for part C, one limitation of the model is that it ignores air resistance. And then we want to state one other limitation of the model that could affect the reliability of your answers. So just like always, yeah, you can say more accurate value of G, or you can say the dimension of the stone or the spin of the stone. Any one of this would be fine. I normally just say more accurate value of G or the dimension of the stone. That's all we need.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.